transient voltage surge suppressor, or TVSS, can be connected with a tap conductor. However, in the described scenario, it is not permissible to connect number 2 conductors to a 600 amp breaker that is rated for number 1 conductors. The correct wire size for the breaker rating, which is number 1 American wire gauge, must be used. Furthermore, it is not permissible to feed a surge suppressor without an additional breaker. The tap conductor must be protected by a breaker or fuse rated at 600 amps. Suppressors can be installed on the line side of the service disconnect, provided they are specifically listed for this type of application. Power frequency voltage refers to the normal operating voltage of the electrical system. For residential applications, this is typically 120/240 volts. The amp interrupting capacity, or AIC, rating is the maximum short-circuit current that the surge suppressor can withstand. This information should be available in the manufacturer's specifications. If it is not readily available, the manufacturer should be contacted for assistance. National Electrical Code, or NEC, Section 285.21 does not prevent the installation of a surge suppressor on a subpanel. However, it mandates that the surge suppressor be specifically listed for use in the intended location. Article 280 applies to surge suppressors intended for installation on alternating current, or AC, systems. Article 285 applies to surge suppressors intended for installation on direct current, or DC systems. In more detail, when dealing with electrical installations and surge protection, several factors must be considered to ensure safety and code compliance. This includes proper wire sizing, overcurrent protection, and understanding the applicable sections of the National Electrical Code. Let's delve deeper into each aspect. Firstly, wire sizing is a crucial aspect of electrical installations. The correct wire size must be used for the specific application to prevent overheating and potential fire hazards. Conductors have ampacity ratings, which dictate the amount of current they can safely carry. These ratings are based on factors such as conductor material, insulation type, and installation method. The National Electrical Code provides tables, such as NEC Table 310.15b16, which lists the allowable ampacities for various conductors. In the scenario described, using number 2 conductors on a 600 amp breaker that is rated for number 1 conductors is a violation of electrical code. A 600 amp breaker requires conductors that are rated to carry at least 600 amps. Number 2 conductors typically do not have this ampacity, especially in common insulation types. Number 1 American wire gauge conductors are more likely to meet this requirement, but the specific ampacity must be verified based on the insulation type and installation conditions. Secondly, overcurrent protection is essential to protect electrical circuits and equipment from excessive current. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the current flow when it exceeds a predetermined level. This prevents damage to conductors, equipment, and reduces the risk of electrical fires. The National Electrical Code requires that overcurrent protection devices be sized appropriately for the conductors they protect. The general rule is that the overcurrent protection device should not exceed the ampacity of the conductor. There are exceptions to this rule, such as when dealing with motor circuits or specific equipment that has its own overcurrent protection requirements. In the described scenario, it is not permissible to feed a surge suppressor without an additional breaker. The tap conductor must be protected by a breaker or fuse. This ensures that the surge suppressor and the tap conductor are protected from overcurrent conditions. A 600 amp breaker protecting a smaller tap conductor would not provide adequate protection, as the smaller conductor could be overloaded without tripping the main breaker. Thirdly, surge suppressors, also known as transient voltage surge suppressors, are devices designed to protect electrical equipment from voltage spikes or surges. These surges can be caused by lightning strikes, utility switching, or other electrical disturbances. Surge suppressors work by diverting the excess voltage away from the protected equipment, thus preventing damage. The National Electrical Code contains specific requirements for the installation and use of surge suppressors. These requirements are found in Articles 280 and 285, as mentioned earlier. Article 280 applies to surge suppressors installed on alternating current systems, while Article 285 applies to those installed on direct current systems. When installing a surge suppressor, it is important to follow the manufacturer's instructions and the requirements of the National Electrical Code. This includes proper wiring methods, grounding, and overcurrent protection. It is also important to select a surge suppressor that is rated for the specific voltage and current requirements of the electrical system. Now, let's address the specific questions raised. Firstly, regarding the installation of suppressors on the line side of the service disconnect, this is generally permissible, provided that the surge suppressor is specifically listed for this application. Line-side connections are typically more exposed to voltage surges and transients, so the surge suppressor must be designed and tested to withstand these conditions. Secondly, power frequency voltage refers to the normal operating voltage of the electrical system. This is the voltage that is present when the system is operating under normal conditions. For residential applications, this is typically 120/240 volts. For commercial and industrial applications, it may be 208, 277, 480 volts, or other voltage levels. The power frequency voltage is important because it determines the voltage rating of the surge suppressor. The surge suppressor must be rated for a voltage that is equal to or greater than the power frequency voltage. Thirdly, the amp interrupting capacity rating is the maximum short-circuit current that the surge suppressor can withstand without failing. This rating is important because it indicates the surge suppressor's ability to protect against high current faults. The amp interrupting capacity rating should be clearly marked on the surge suppressor. If it is not, the manufacturer should be contacted for assistance. Fourthly, regarding NEC Section 285.21, this section does not prevent the installation of a surge suppressor on a sub-panel. However, it does require that the surge suppressor be listed for use in the intended location. This means that the surge suppressor must be tested and approved for use in the specific type of electrical system where it is being installed. Finally, to determine whether Article 280 or 285 applies to a particular surge suppressor, you need to consider the type of electrical system where it will be installed. Article 280 applies to surge suppressors installed on alternating current systems, while Article 285 applies to those installed on direct current systems. In summary, when installing a TVSS and understanding the relevant electrical codes, one must pay attention to several key points. These include proper wire sizing, which must match the breaker rating and ampacity requirements, and the necessity of overcurrent protection for the tap conductor feeding the surge suppressor. Always ensure the surge suppressor is listed for its intended location, whether on the line side of the service disconnect or on a sub-panel. The AIC rating indicates the surge suppressor's ability to withstand short-circuit currents and should be readily available from the manufacturer. Finally, determine whether Article 280 or 285 of the National Electrical Code applies based on whether the system is alternating current or direct current. These considerations are crucial for ensuring safe and code-compliant surge protection in any electrical installation. Always consult the latest edition of the National Electrical Code and the manufacturer's instructions for the most up-to-date information and requirements. In addition to the topics already discussed, several other factors should be considered when selecting and installing surge suppressors. Firstly, the type of surge suppressor should be chosen based on the specific application. There are several different types of surge suppressors available, each designed for different types of electrical systems and equipment. For example, some surge suppressors are designed for use on branch circuits, while others are designed for use on service entrances. Secondly, the surge suppressor's voltage protection rating should be selected based on the voltage level of the electrical system. The voltage protection rating indicates the maximum voltage that the surge suppressor will allow to pass through to the protected equipment. The voltage protection rating should be as low as possible while still being high enough to prevent nuisance tripping. Thirdly, the surge suppressor's surge current capacity should be selected based on the expected surge current levels in the electrical system. The surge current capacity indicates the maximum surge current that the surge suppressor can withstand without failing. The surge current capacity should be high enough to handle the expected surge currents in the electrical system. Fourthly, the surge suppressor's let-through voltage should be considered. Let-through voltage refers to the amount of voltage that the surge suppressor allows to pass through to the protected equipment during a surge event. A lower let-through voltage is generally better as it provides greater protection for the equipment. Fifthly, the surge suppressor's response time should be considered. Response time refers to the time it takes for the surge suppressor to begin clamping the voltage during a surge event. A faster response time is generally better as it provides faster protection for the equipment. Sixthly, the surge suppressor's clamping voltage should be considered. Clamping voltage refers to the voltage level at which the surge suppressor begins to divert the surge current. A lower clamping voltage is generally better as it provides greater protection for the equipment. Seventhly, the surge suppressor's warranty should be considered. A longer warranty typically indicates a higher quality product. Eighthly, the surge suppressor's listing should be verified. The surge suppressor should be listed by a recognized testing laboratory, such as Underwriters Laboratories or all. This ensures that the surge suppressor has been tested and meets safety standards. Ninthly, the surge suppressor's installation location should be carefully considered. The surge suppressor should be installed as close as possible to the equipment being protected. This minimizes the length of the wiring between the surge suppressor and the equipment, which reduces the impedance and improves the surge suppressor's performance. Tenthly, the surge suppressor's grounding should be properly installed. The surge suppressor should be grounded to a properly grounded electrical system. This provides a low impedance path for the surge current to flow back to the source. 11thly, the surge suppressor's wiring should be properly installed. The wiring should be sized appropriately for the current being carried. The wiring should also be installed in accordance with the National Electrical Code. 12thly, the surge suppressor should be inspected regularly. The surge suppressor should be inspected regularly for signs of damage or wear. If any damage or wear is found, the surge suppressor should be replaced. 13thly, the surge suppressor should be maintained properly. The surge suppressor should be maintained in accordance with the manufacturer's instructions. This may include cleaning the surge suppressor and tightening the connections. 14thly, the surge suppressor should be tested periodically. The surge suppressor should be tested periodically to ensure that it is functioning properly. There are several different ways to test a surge suppressor. One way is to use a surge tester. A surge tester generates a surge voltage and measures the surge suppressor's response. Another way to test a surge suppressor is to use a multimeter. A multimeter can be used to measure the voltage across the surge suppressor during a surge event. By following these guidelines, you can ensure that your surge suppressors are properly selected, installed, and maintained, and that they provide the best possible protection for your electrical equipment. Remember to always consult with a qualified electrician for any electrical work. The National Electrical Code is a comprehensive document that contains many requirements for electrical installations. It is important to be familiar with the National Electrical Code and to follow its requirements when installing electrical equipment. Ignoring the National Electrical Code can result in unsafe electrical installations that can cause damage, injury, or death. Electrical work should only be performed by qualified individuals who are familiar with the National Electrical Code and who have the necessary skills and experience.